After getting a healthy dose of theory, let's try to use our theoretical knowledge to create a complete Swift application. We'll use the Xcode environment. Let's start with an easy program, a tip calculator. You probably often ran into a problem that you wanted to quickly calculate how much to tip and how much should be paid by the person who is at a dinner with you if you go Dutch. Our application helps users to easily make such calculations. Let's start the Xcode environment and create a new project. From the available options, we choose Create a new Xcode project. Then we choose Single View Application from the available templates. Now, after checking the Next button, we specify the basic properties of our project. Let's call our program Tip Calculator. We choose Swift as the programming language. If iPhone isn't available as the default device, we choose it from the list. Let's also make sure that the Use Core Data option is not chosen. Now, all we need to do is specify the location of our project. After clicking the Next button, Xcode will create all the files we need. This is what the default Xcode environment screen for a new project looks like. As a default, our application will only work in portrait mode. That's why we deselect the landscape left and landscape right options right away. Before we start writing the code, let's just add the icon of our application. From the tree on the left, we choose Images Xcode Assets and then App Icon. We drag the icons we prepared earlier to the relevant fields. All the necessary files are present in the kn_res directory. In our program, we'll use only 3 icons: an icon small application setting icon, a spotlight icon small 40, and an application start icon 60. All our icons are adjusted for operation with high-resolution Retina displays. Additional information about the required and recommended graphical files, the icons, start images, their dimensions, and the intended application can be found on Apple's technical sites. Now let's try to launch our code. As we can see, so far the result of the operation of our application is not too interesting. It's just a white screen. Let's just check whether our application icon looks correctly. To do so, let's choose Home from the Hardware menu of the simulator. As we can see, everything looks okay, so we can close the simulator. Let's return to Xcode and start building the application by creating the user interface. From the panel on the left, we choose the main storyboard. Before we start modeling the interface, we need to modify several view properties. Let's click the View controller and on the right-hand side, switch to Attributes Inspector in the 4th tab. In Simulated Metrics, the first section from the top, we set the simulator size to iPhone 4-inch. We also change the color of our background view. Let's make it green. Now, let's add all the necessary interface elements: 3 editable fields, 11 labels, and one button. We start by adding the text field. We place a single such field in our view and specify all the necessary parameters. We set the background color to a slightly brighter green. Now, let's specify the properties of the keyboard that appears after the text field is chosen. As our view, we choose Dark from the drop-down list and set the keyboard type to decimal pad. Let's also change how the Clear button behaves. From the drop-down list, we choose Appears while editing. Our first text field is ready. Since all our fields have similar properties, we can just use the copy-paste command to create the other two. Now, let's deal with creating labels. In this case, each label will be different. That's why we'll add them separately one by one. There are already 4 labels. We need 6 more. Now, we have to correctly configure each label. Let's start from the header, which will be visible in the upper part of our application. We will specify its name, font, and location. Since it's a header, let's use a slightly larger font. To finish up, we place the header in the appropriate place of the view. We do the same thing with the remaining labels. After determining their text, we place them in the right place of our view. The bill amount, tip percentage, and the number of people will get appropriately aligned with their text fields. The text fields and labels related to the input data are now ready. Now let's move on to the ones that represent the calculation results. The first label is the tip amount. We set its location just like we did with the previous labels. In the case of labels on the right side, we leave the default value. We display the actual value only after the calculations are made during the application's operation. We do the same with total payment and payment per person. All the labels are now ready. Now, the last interface element we have to add is the button. Let's place it above our recently added labels. To make the button stand out from other interface elements, we'll change its size, font, and color. The interface of our application is ready. We just need to add an appropriate model to it. Most often, the model consists of one or more classes, represents the data used by our program, and specifies what operations can be executed to it. Now let's create a new class and name it Tip Calculator Model. To do so, we have to create a new file and choose Swift File from the available templates. Our model will consist of 6 variables representing, respectively, the bill amount, tip percentage, the number of people we want to split the bill with, the calculated tip amount, the total amount to be paid, that means the tip plus the bill amount, and the amount paid by each person in case we want to split the bill. It will also have 2 functions, init and the function that calculates the values we mentioned earlier. That is the tip amount, the total amount to be paid, and the amount to be paid per person. The 2 first variables, the bill amount and the tip percentage, are double type. The number of people, in turn, is int type. All the values calculated by our program will of course be double type. The tip amount, total amount to be paid, and the amount to be paid per person. In this case, we'll also initialize all the 3 values with 0 values. Now we add the init method. Based on the provided parameters, this method will initialize the values of the bill amount, the tip percentage, and the number of people. At the very end, it will call the calculate tip method, which we will add in a moment. In this example, we can also see how to distinguish method parameters from class properties. The self keyword helps us a lot here. The calculate tip function will calculate the amount of the tip for us, the amount to be paid in total, and the amount to be paid per person based on the model data. With the interface and the model of our program ready, all we have to do is to link everything in the view controller. From the tree on the right, we choose the view controller Swift file. The code visible on the screen is the default code of the view controller generated by Xcode. We can add the relevant outlets and actions to this code so that the user interface is linked with the model. We can do it in two ways. By adding everything in the editor and correctly connecting new elements in Storyboard, or by using the Assistant Editor. Personally, I prefer the first method, but beginner programmers usually use the Assistant Editor, so I'll demonstrate the second approach. Let's choose our storyboard from the tree on the left and then the Assistant Editor. We choose the first editable field and then pressing the Control button, we left-click on it and drag it towards the editor. At this moment, Xcode asks us what kind of connection we want to create. Is it supposed to be an outlet or an action? In our case, it's an outlet which we'll name bill amount. Obviously, it's a link to the UI text field. After entering the name and clicking connect, Xcode adds the relevant line to the controller code. In the same way, we create the links for the two remaining editable fields and three text labels that represent the calculation results. All right, the text fields are done, so let's move on to link the labels. We do everything just like in the case of the text fields. In the buttons case, we'll have to choose the action from the Xcode dialog box. The code added by Xcode will also look a bit different. Now, we must make sure that selecting the button performs the right operation and that the information on the screen is refreshed. Before we deal with the screen refresh, we initialize our model by adding the appropriate declaration. This line initializes our model with a bill of 100 zlotys, to which we want to add a 10% tip. We want to split the final amount between two people. We write a new function to refresh the screen and add it to the ViewController class. In this method, we first assign the data stored in the model to the text in text fields property, and then to the text in labels property. All the values, apart from the one that represents the number of people, will be displayed up to two numbers after the decimal point. And now the results of our calculations. In order to see the result of the operation of our function, we add its call at the end of the viewDidLoad method. Now, the moment we start our program in the simulator, we should see the calculated tip amount and the full amount to be paid. Of course, if we try to change the amount of the bill, the tip percentage or the number of people and press the calculate button, nothing will happen. we haven't implemented the right method yet. So let's stop the program and return to the view controller code in order to modify the calculate tip method correctly. In this method, first we have to read the values from the user interface. The bill amount, the tip percentage, and the number of people. Let's also add a small input data check. If someone enters a number of people that equals 0, we'll change this value to 1. Now let's calculate how much the new tip should be and refresh our view so that the calculation results appear on the screen. Before we test our program again, let's add yet another code line in the viewDidLoad method. We do this so that the keyboard is visible immediately after the program starts and to make the bill amount an active field. Now we can test our program once again. If we did everything correctly, after changing one of the parameters and selecting the Calculate button, the screen will display the results of the calculations based on the new values. And there you have it, our application built from scratch. If you want, you can develop it on your own and try adding the following elements. Controlling the tip percentage scope value. You can even enter as much as 1000% now. Change the percentage scope value control UI text box to a slider with a specified min-max scope. Implement automatic calculations of the tip amount, the full amount to be paid, and the amount to be paid per person the moment the value of one of the variables is changed, without the need to select the Calculate button. Add a feature of rounding out the total amount of the bill and the amount to be paid per person. I mean, nobody wants to look for the exact amount in loose change. Or automatically implement the automatic storage of the values introduced by the user between application starts.